Now here, what is the probability that the sum of the numbers obtained on the dice will be at least 8, given that the number on the first die has 4? So 2 dice are rolled, whereas on the first die 4 is fixed. Now second, what is he asking is sum of the numbers on this die must be at least 8. So at least 8 is nothing but greater than or equal to 8. So if the first die has 4, second die can be 4, 5 or 6. So there are only 3 possibilities out of 6. So the required probability is nothing but half, which is option A. Problem. Now we have to translate the statements given into English. Now the statements given are B of x represents x rides bicycle and f of x comma y represents x and y are friends. And what are these x and y are nothing but the students of a school. Now we have to translate this into our general English language. Now, in order to translate this, first let us translate this inner part, which is f of x comma y and b of y. F of x comma y is nothing but x and y are friends. B of us is nothing but those who ride bicycle. So the friends who ride bicycles, friends, at least one, the friends who rides bicycle is nothing but the combination of f of x comma y intersection b of y. Now let us combine this total statement for all of them, for all the students in the school. Those who ride bicycles, or this we represents or there exists at least a person who rides bicycle. So it is nothing but every student in the school rides bicycle or has a friend who rides a bicycle, which is nothing but option C.
Consider the following grammar. The productions are given like this: S to SS, S to 0, S gives epsilon. Which of the following is true related to the given grammar? Actually, some statements were given, 4 statements. Among these statements, we need to find out the true statements. The first statement is it is ambiguous. Second statement is it is left recursive. Third statement is it is LL1 grammar. Fourth statement, it accepts 0 plus. So here the given grammar is S2, SS is one production, 0 is one production, epsilon is one production. So when S gives epsilon, the minimum string generated by this is null string. That means this option 4, that is statement 4, is wrong, because it is saying that it accepts 0 plus. 0 plus does not contain epsilon. So that this statement is false. It is not an LLM grammar. It is left recursive and both right recursive. And one is it is ambiguous. A grammar is ambiguous usually when a grammar is both left recursive and right recursive. It is left recursive because the deriving variable s is repeated here, and also the deriving variable s is repeated on the right side also. It is both left recursive and right recursive. So it is ambiguous. And one more definition for ambiguous is whenever if you want to take any derivation over a particular string generated by this grammar, let us suppose if you take single 0, we can have more than one derivations. Either it is leftmost or it is rightmost derivation, so that the grammar will become ambiguous grammar. So for example, if you take 0 generation, S to SS, we can take one production. I can replace this S with epsilon so that you can get single S, and this S can be replaced with 0 because S derives 0. So this is the sequence of productions we have applied for the generation of 0. Let us go with another sequence that is also possible because it is an ambiguous grammar. S2 SS, here the first S I will replace with 0 and the second S I will replace with epsilon. First we take S2 SS and this leftmost S is replaced with 0, and again this S is leftmost, this is replaced with epsilon, we got 0. So the same derivation of 0 is possible by going with different sequence. That means the grammar is ambiguous. It is left recursive also. So 1 and 2 are the true statements. So option C is the correct option. 1 and 2 are the true statements here. Which of the following languages is /r context free? L1 is equal to a power I b power j, a power I b power j, such that I comma j greater than or equal to 0. L2 is equal to w belongs to 0 comma 1 whole star. The length of W is odd and its middle symbol is 1. So in these two languages we need to find out whether only L1 is CFL or L2 is CFL or both are CFL or both are not CFLs. So here in L1, if you take I number of A's followed by J number of B's, again I number of A's followed by J number of B's. So normally when you construct a push down automata for this, if you try for the push down automata, we can push A's into stack and we can bypass B's because I and J both need not to be the same. But the number of A's after B's must be equal to the first A's, that is I number of A's. We can pop those A's but using these A's, but the same number of B's we cannot bypass. Here two counts we have to maintain equally. So this A must be equal to this A's number of A's and the number of B's of this must be equal to number of B's. So two counts we can't maintain equality using a single stack. So that L1 is not a CFL. We cannot construct a push down automata for the language L1. Let us take language L2. W is the word here which is of zeros and ones. The length of W is odd and its middle symbol is 1. So we can have a grammar like this for that. That is S2 0S0 or 1S1 or 0S1 or 1S0 or 1. Here the middle symbol always becomes 1 because if you use only single one, so this is middle symbol 1, the length of the string is 1, so this is odd. That is the smallest string in this language. The length of W is odd and its middle symbol is 1. For example, if you want to have a middle symbol 1, before and after we may have 0 0 or we may have 1 1 or we may have 1 0 or we may have 0 1. So for these combinations we should have 0 0 1 1 1 0 0 1 combinations. That's why 0 S0 will replace that and 1 S1 and 0 S1 and 1 S0. So that if you take any of these productions like for example S2 1 S0 if you are taken, again this S can be replaced with some 0 S0, okay, and then this S can be replaced with 1, so that the length of the string is 5 but middle symbol is 1. So any string you take whose length is odd and its middle symbol is 1, that will be generated by this grammar. So that when the grammar exists, that is CFG, so given language is a context free language. So only L2 will be the context free language, L1 is not a context free language. So that option B is the right option here.
It is given that 50% of the glasses produced in a glass factory are defective, and we have to find the probability that exactly 2 glasses will be defective when we select 10 glasses. So probability of getting 2 defective glasses when we select 10 glasses would be P of x is equal to, which is equal to 10C2. We are selecting 10 glasses. So here defective glasses, getting half of them are defective. So here 1 by 2 whole power 8, 1 by 2 whole power 1 by 2 whole square into 1 by 2 whole power 8. So here if we simplify this, we will be getting 45 by 2 power 10. So here correct option is option C.